In this session, we're going to review the cul-de-sac design and street intersection routines. So going into coordinate geometry, we are going to look at the job directory again. And we see cul-de-sac demo file, which is job 3. So we will just do something a little different. Right-click, load a job 3. Again, Northing and Eastings. And we should do a 1 minus just to get everything in print mode. And then we should do a 210 minus, which is print all the points that are available. So these are the points we started with. A couple of zeros I put in there because I had some input error problems that I cleared out by putting zeros in. Other things to look at here. This is the first, this section here, which is page 22 of the samples manual. Starts off with the cul-de-sac design, and this is the first one we're going to do. And again, in this section, I'm not going to do all the examples either, but I'll do a couple to get the flow of how these are done, and then those of you that are doing the examples live can do as many as you like. I think I've included all the points that you need to do all the examples in the in the points that I put in there. Also, on the mini manual reference section, chapter 10 covers both street intersections and cul-de-sac design. These are the different kinds of cul-de-sacs that you can design, and once you've done this once or twice, these sheets here are pretty good reference material for getting you through the process without having to go to the big book, if you would. And if you do go to the big book, it's chapter 10, and it's called Street Design Commands, but as you can see here, we have the cul-de-sac routines, and the straight street intersections and the curved street intersections are all part of this chapter. Here we're looking at the on page 244 of the main manual, exactly halfway through. You can see the different commands for the cul-de-sac routines and the detailed instructions for entering each bit of information, and a very detailed diagram that talks about the different variables and what they are and how they're thought about and used. Okay? So we're going to go back to our example here and do this one first, and I'll do 1 or 2 of these, and then I'll set up the plot files, just make up groups and plot these so that you can see how that process goes as well. Go back to benchmark, and for the first example we'll need to do a 163. I think I'll just do a 10 minus to sort of get into benchmark and get that little banner line right here. Then I'll do a 163 minus to ask for the first storage point, and we'll say 210. Point A minus 11. The minus defines the reference to whether it's left or right of the point it's using for a reference. That's well documented in that section of the manual. But you do need to know, depending on what you're looking at, whether you need to put a minus sign on the point number to make sure that it understands its relationship to the other known point. In this case, point C is 12. The offset distance is 25. And we calculate our first point, which is 210. Radius length is 50. The street width is 50. That gets us our first 2 points. And then our second radius is 25. Creates the rest of our points. Gives us our curve data. And our last points So it's created 210 through 217. If we go back to the drawing here, we can see that we started off with, and I suppose I need to come down here a little bit to 11 and 12. And from these 2 points and that information, the radius here, the big radius of the curve, and the street width, etc., we were able to calculate all these points that define that particular Cullen Street intersection. For our next example, I thought I'd pick something a little different, and so we're doing this. This is the street intersection here, which is a curved street into a straight street, and we know this point, the point of the intersection, and I think we know this point on the street. We know the big radius, and we know, or we're going to define or enter each of the radiuses for each of these intersections, and it's going to calculate all the dependent points. So here we're going to do that, this intersection right here that I talked about a minute ago. So we are going to select the command 175 minus, which is the command for doing that type of intersection. And I'm going to pick a storage point of 526. It's asking me for point A, which is 19, point B, which is 20, and point C, which is 21. First street width is 50. Second street width is 50, though these obviously don't have to be the same. The first little radius is W1 is 15. Second little radius is 25. Third is 15, and the fourth is 20. And it calculates all those points and gives you all that curve data. And that is how that intersection routine goes. And you can match those points up in that printout to the points that appear here. Next thing I'm going to do is actually set up the groups for plotting this out, just so you can see how that's actually done. If we look at the street intersection routine that we built with the 175 minus, you'll see it's actually 6 disconnected lines. So we'll have to actually make 6 little groups to get those lines in there, so that the resulting plot looks, you know, exactly like the diagram we were looking at on that page. So to do that, I'm going to enter 130 minus to create a new group. There are no groups in this particular thing, so I'm going to add a group, and I'm just going to call these groups 1 through 6. So it's going to be group 1. Name is line 1, just to give it something. It's open, and all I want is point numbers, and so this one I'm going to use 545 to 528. Radius point is 526. To 527. We have another radius point, because into that curved part of the street now. And the radius point is 21. And the ending point is 542. And that takes care of line 1. So we'll add a group, and we'll call it group 2. And we'll call it line 2. And it again will be open, and it will be point numbers, and we'll do the lower right section now, and we'll start that at 548 to 531. Radius point 529 to 530, another radius point, which is 21, and end up at 543. And that will take care of that line. I'm now doing the last group, which is the curved line from 538 through 19 to 539. And the way I'm doing this, I'm going to start at 538, and then I'm going to RP my way. Radius point is 21 for that curve to point 19. And then I'm going to RP it again back to 21 and finish up on 539. The only reason I did that was so that point 19 shows up in the middle as the intersection point. I didn't leave the recorder on for all 6 of these lines because I don't want to put you guys to sleep with my droning, but I'll show you the ones that I created while I wasn't recording. This is the lower left corner of the intersection, and you can again look at all these and kind of follow when you look at the drawing, see how the points match up. You can pause the video while you match things up to see what I did and why it works, because I haven't really plotted this yet. We may find out I made some mistakes for all we know. Here's the 4th one. This is the upper corner. So I'm not going to bore you flashing each one up in front of you, but having had this done now, we can close this and we can do a 127 minus, accept all the defaults again, grind our way through this, say OK, and we're going to call this the 175 minus demo, since that's what we were doing. And we'll say it's automatic labeling, inside, outside, yes, no. And okay, 113, sure, I'll say 1 equals 20, why not? 1 right, 2 left, sure. And I have a feeling that we have a problem here. I must have entered something incorrectly because we have kind of the same thing that happened before. So let's go see if we can figure out what exactly happened to us here, because we are definitely in trouble. Haha, I'm not even sure that I can zoom this out far enough to find out exactly what happened. So, wow, very interesting. I'm going to try to zoom in on this section right here. There's the table. There's some stuff. There's obviously some points that I misentered here that I'm going to have to take a look at. So, there we go. We can take a quick look at this little table here, which is very nice. But obviously I have some fixing to do here, so I'm going to go find out what I did wrong. Then I will turn the recorder back on, explain to you what I did, and go from there. Actually, I found the reason we have a problem is because I never really calculated any of these points here yet. And from 538 on up to 549 or 48, whatever it is, so therefore those all went to 0 and it went crazy, which of course makes perfect sense. So what I'm going to do now is actually go back and calculate those points, because that was the next page in the samples manual. So with that, we will set on 10 minus, so we will occupy point 19, and we don't have any backside we're involved with right now. We do want to start storing at point 538, and we are going to accept that, and we're going to work our way around a curve. Radius point is 21. The arc length is minus 100 because we're going counterclockwise. And we have thus calculated 0.538 and gotten the curve data. We will go back and occupy 0.19 again, and start doing at 539. Same act, same radius point. This time we're going clockwise, so it's 100 feet, and we've taken care of 539 and gotten all our curve data. Kind of the same thing over and over again here. So this time we're going to occupy 0.538. And again, we'll ignore the back side. We're going to go to 540. Going to do a side shot. Going to define a direction from 0.21 to 0.538. A distance of 25 feet. And calculate point number 540. And again, come back and sit on 538. We are going to define a direction again, this time from 538 toward 0.21, a distance of 25 feet. And we will calculate 0.541. And again, we're back sitting on 538. Now forget all that, go occupy a new point. 539. No back sight. Going to be storing 542. This is again is a kind of a repeat of what we did last time on the other side. Defining a direction from 21 again toward 539, a distance of 25 feet, and we calculate 542, and we can define direction again from 539 towards 21, distance of 25 feet, and calculate 0.543. Then the last thing we're going to do is go back and occupy another point. We'll occupy 0.19, no backside, start storing at 544, side shot again, define bearing and length, direction and distance, and using from 20 to 19, basically copy that line and calculate 544. And sit back on 19. Now we're going to do the 180 minus for the offsets. And we're going to go 25 and 25. And reference point 20. And look at 545 and 546. Asking for the other reference point, which is 544, and we'll get points 547 and 548. We have this other nifty little command, mostly for the days of manual plotting, called 222 minus, and it scans all the points and it shows you the most northern, southern, easting, and westing. Now, because I have some zeros in there, this can be misleading because I have a 0 at 24 and a 0 at 24. So if I cleared those points out and made them nulls, I would get the actual information I wanted. But having those points in the system now, what we can do is we can go back to our 127 minus routine and do our 175 minus example. And take all the defaults. We'll do the 20 again. 1 and 2 and OK and OK. Let's see what happens. Ah, now we have a figure that looks almost like what we were looking for, but still with a couple of, you know, these things here are right. Got a little problem over here and a little problem here in that I didn't quite make that arc around there. So I'll need to look at my batch file one more time. I'm okay in the middle here. Let's see if I can change the view here to get that straightened out. Look at that. So I'm going to go back one more time and analyze why we had that particular issue and go from there. The problem turns out to be in, if you go back and look at the drawing in the lower left-hand corner, that little radius from 534 through 532, that number is actually 533, not 539. So if we change that to 533, I think everything else corrects itself. So there's our fix. We say OK. We can close this down. And now you can see with that simple fix, now everything matches up the way it should. We have a picture that's exactly like the one that we created before. So this again is nice because we can window in wherever we want and quickly go back and get the whole picture and take a look in somewhere else if we want to get close and look at things. So this is pretty neat, and then of course we can right click here and pan around so we can slide this baby around and kind of look at it the way we want to. So it's a really pretty nice tool for making sure that your stuff is sane. And I think that's pretty much everything I wanted to show you in cul-de-sacs and street intersections. There are a lot of other examples here, and you can run them all and go through kind of the same exercises I've gone through here to see how everything works.